So in today's video we will discuss about all the delay control, event control, any type of delay, any type of wait statement, anything inside our Verilog or system Verilog also, because all the things are repeated in system Verilog as well. So first is our delay control, then event control is there, then name dimensions are there, and event or operator. Here or operator. Now implicit event expression list, it is related to this, and level sensitive event control also related to this, or you can say these three. Wherever the event are used, they are similar concepts, but have some different use, you can say. Now first is our delay control, and this is third time I'm covering this topic, is inter delay, so I will mostly revise it. So we are using this before variable or expression or your statement, this delay. So it has simple working functionality, like we will give some delay, and after some unit time, whatever it may be, like nanosecond, femtosecond, microsecond, will execute. So we have declared two variable a and b, so it will be executed at 0, will execute 0 because there is no delay, but after 5 unit b equal to a will be there. So this is the working of our inter delay. Second is our intra delay, and intra delay RHS delay, because it is easy to remember because we use mostly in RHS. So same thing, it will execute 0, it will execute 0, but here b will execute at 0, but b will get value of a at 5 unit. So b equal to 0 will be there at 0, and b equal to what is the value of a? 1. So b equal to 1 will be at 5 nanosecond or 5 unit. So this is two types of delay. It use changes with our blocking, non-blocking, event regions. We have to use event regions for understanding deeply this concept. I have already covered this in 2 videos before this video, so you can watch that video. And our second is our event control. So event control mostly is our at the rate statement we are using, like with negage and passage of clock, right? So what happens is it is going from something 1 to z, x or 0. This type of thing is happening in your clock or in your any signal, it will trigger. So this is event control, means triggering event. What is trigger for that? If 1 is going from x, z or 0, or our x, z is going to 0. So this is also one event, negage of event. Opposite of that is our passage of event. For example, if our 0 to xz is going up, so this is our 1, or from x, z or 0 to something is going to 1. So in this type of cases we use this negage and passage. So here is one example, like at the passage of a. So whenever the, for example, this is our clock, so whenever this passage will come, this statement will execute. Similar for b, let's give it name of clock, or this clock is our a because it is working on a, so it will be a. So when a signal is going, whenever there is passage, so this statement will execute. Now passage of a plus b. So this is different use of this at the passage of clock. We mostly not use this type of thing, but it is one of the concepts. Only now here a is not used with passage or negage of clock. So what is happening whenever there is changes in a, like from a is going from 1 0 1 0, so it is changing now 1 to 0 0 to 1 1 to 0. So in every change it will execute.
Hit subscribe, like, and comment now. Let's begin the journey of verification.
The meaning of this is this. And passage of a plus b is whenever these two are having passage or changes simultaneously, you can say, then it will be changed. You can execute these things and you can see the results. Now third is our named events. So it is little bit different because it is not used similar to our intra delay or this our previously slides passage triggering events. It is triggering event but not used like you are at the passage of clock. So The keyword event can be used to declare the name event which is be triggered explicitly. So you can understand this thing, like event is one keyword and similar to your data type, you can say, and it is triggering. Okay, so two things is clear, that we will use event as a keyword, and some triggered mechanism will be there. Now an event cannot hold any data, so this event is used like a data type but cannot hold any data, has no time duration, and can be made to occur any particular time. So what is the thing this statement is saying, that it is not like sequential, like inside initial begin you are using your inter delay or intra delay, it will execute at sequential manner or sometimes in parallel manner if you are using for conjoin. But here event is not restricted for that thing, and event, a name event is triggered by this operator. So you need these two things, event and this operator. We are using both simultaneously by prefixing it before the named event. So we will see in the next slide. Named event can be waited upon by using @operator and describe above. So we can also use @ for, and waited means you can also use wait keyword also. So how we are using this? So simple, we are taking this event keyword and we are using at a event as a keyword. So at 20 delay, inter delay, we are executing this event. Okay, now we are executing means we are triggering this event. Whatever will be inside your event, we don't care. We are executing this event at 20. So this is one parallel working block, this is one parallel working block, this is one parallel working block. Everywhere you can use this event. So what will happen, this event, this event, this event will trigger at their own respective time. Okay, so this will execute after 50. Same event, this event, whatever you have written in event, there are different uses for that, but now we are seeing only how to trigger this event. Now you can use @event. So @event means whenever their event will be changed, or whenever there will be an event, always you are using, so it will check every time, this statement will execute. So now you are using this event statement for execution of this display statement. Here you can write one statement and you can execute that. Okay, now third thing is this is the example for writing like three different blocks are working parallelly. One thread is there, two thread is there, and third thread is there. So one, two, and third. These three threads are working simultaneously parallelly, and every time the event is triggered. Now I also said that wait is also one event you can use. So you can also write wait a_event. So what will happen, if some statement is written here, like our display statement is written here, it will wait until this event is there, then only the next line will execute. So wait is also one part of this event, named event. Now or operator, as I mentioned earlier, this is our passage and this is our another passage of clock, or maybe negation of clock, whatever there is. This is a synchronous type of thing or synchronous type of circuit you are executing, then you will use this or. Like it will also depend on this, it will also depend on this, so you can write with the help of or. Now this is different from this. Okay, here it is asynchronous and it is a flop or sequential circuit. Triggering event is there. Here we are using triggering event. Here implicitly event expression list, what is there, this sensitivity list are here, means whenever their inputs are changing, a b c d, whenever these are changing, it will execute. So this is creating a combinational circuit and this is creating a sequential circuit. So these things are there in delays, and comment me for another topics or whatever topics you need. I will help you in your verification career. Thank you.
Please, Lord, give me a sign, a sign.